Hi, this is Rohan from educator.ai. Let's dive in. Welcome. In this video, we build up tool calling, sometimes called function calling. By the end, you should be able to review a pull request that uses it and spot the dangerous bits. Here's the problem. A language model only predicts text. Ask it today's weather or a customer's order status, and it has no way to look. It cannot query your database or hit an API. Tool calling is the bridge that lets it reach out to your code. Think of the model as a manager and your code as the intern. The manager writes a work order that says which tool to use and with what inputs. Your code does the actual work and returns the answer. Crucially, the manager never runs anything itself. Step 1 is entirely yours. You describe each tool, a name, a short description, and a schema listing its arguments and their types. This description travels with the prompt, so the model knows what it may call and how. Here's a real tool description. Notice, it is just data, a JSON schema. It says the tool is called get_weather and takes one required string, city. The model reads this. It does not see your implementation. Step 2. Given the prompt and the tool schemas, the model decides it needs the weather and emits a structured call, the tool name plus arguments filled in. This is not prose for the user, it's a machine-readable request aimed at your code. Step 3 happens in your runtime, not the model's. You pass the call, validate the arguments against the schema, and only then run the actual function. This validation step is where a careful pull request lives or dies. Never trust the arguments blindly. Step 4. Your function returns a result, say 14 degrees and rain. You append that result to the conversation as a tool message, tag to the call it answers, and hand the whole thing back to the model. Step 5. The model reads the tool result, now sitting in its context, and continues reasoning. It might phrase a final answer for the user, or decide it needs another tool call. That's the loop. Here's the full picture. The model proposes, your code disposes. The boxed steps, validate, run, append, all happen in your runtime. The key insight for reviewing code: the model never executes anything, it only ever emits text describing a call. If a pull request lets the model's output run directly, that's a red flag. In code, the loop is small. Call the model with the messages and tool schemas. If it returns tool calls, validate each one, dispatch to a registry of allowed functions, and append the result. 2 review notes. Validate before you dispatch, and in production cap this loop, so a model can't spin forever and burn tokens. Let's make it concrete. Here the model's call is a JSON string. Our code parses it, checks the tool name is in an allow list, checks the arguments are expected keys, and only then runs the real function. The model produced text, our code did the work, run it, and you see the tool name and its result. The biggest misconception: people think the model runs the function. It does not. It emits text you choose to execute. So treat those arguments like any user input. A prompt-injected document could make the model emit a call to delete records. Validate scope, allow list tools, and never pass raw arguments into a shell or query. Use this as your review lens. On the left, correct. Arguments validated, tools on an allow list, the loop bounded with a cost cap, and tool errors fed back cleanly. On the right, the red flags: arguments dropped straight into SQL or a shell, evil on model output, an unbounded loop, or sensitive data leaking into a chatty tool. If you see the right column, request changes. To recap, you describe tools. The model emits a structured call. Your code validates and runs it. The model never executes anything. You feed the result back, and the model continues reasoning. When reviewing, always check for validation, an allow list, and a bounded loop. That's tool calling.